Hi everyone. In this video, Mark is going to show you how to use the peak modeling features in ProMass HR. These are used to sharpen the peaks and improve resolution. In the second part of the video, Mark is going to show you an example of peak modeling using a myoglobin spectrum. He'll also discuss why you might want to create multiple models depending on your data. Reference our ProMass HR Quick Start Guide to see more information about using the software.
It's going to try to create a peak model for your data. So it's going to take the peak shape inherent with the instrument and it's going to generate a data model. And the reason it does that is once it has what a peak should look like, it's able to use that and operate on your spectra using this peak model. And it can improve the resolution of the data once it knows what the data should look like. So you can see it's done quite a good job here of mimicking what the peak shape actually is for the Orbitrap resolved data. And if you're happy with these settings, you can click Next. One thing to point out is like the shape factor here. The shape factor, you'll see you have a left shape and a right shape, and you have a left width and a right width. These affect whether the peaks are Gaussian or not. So a shape factor of 2 is perfectly Gaussian, and a shape factor of 1 is Lorentzian. So you can tune these depending on what kind of data the instrument is generating. In the case of Orbitrap data, it's generally Gaussian. If it's resolved. If it's non-resolved data, the peak shape can be less Gaussian. But we're creating a deisotoping method, so in order to have a deisotoping method, you have to have isotopically resolved data. The numbers are actually slightly higher than Gaussian. That probably means that at the foot they've been chopped off a little bit, and that actually kind of makes sense based on the way the thresholding is done on the Orbitrap. But, so you can click Next. Now the deconvolution here is not really charge deconvolution at this point, it's actually peak deconvolution. So it's going to take our model and it's going to compare it with the data and it's going to generate a deconvolution. So for this degree of fit, generally I select a value of 2, and this is printed in the guide, but I found that to be a more forgiving number. And I want to use the whole spectrum, so I want to say no to this. You do have to generate a model of your data. There is like a myoglobin test file. It's one of my faves. This is more or less instrument specific, so you need to generate the model on the instrument and the mode. But I'll just show you, like using this myoglobin spectrum, how you would actually generate a model from something like this so that you could use it to sharpen the peaks. So again, the process is the same way. You export the data to the clipboard and then you go in, launch review again, paste it in, and then again it's prompting you for the various steps. So it's going to try and remove the baseline first. Now when it's generating its model, it's going to just pick like the biggest peak in the spectrum and it's going to generate a model for that peak. So you can see it's done a pretty good job here. Done more or less a kind of close to Gaussian peak here. One of the things that you can do now, if you expect your data to vary across the range, you can actually generate multiple models. And this is kind of important because PPL is expecting more or less a constant width. And if the width changes significantly, that's a good idea to generate multiple models. For the Orbitrap resolved isotope data, we only need a single model because the width is always the same. If you look at any time when it's resolved, even when you change the resolution, the number of data points that Excalibur requires across a peak is constant, which is actually kind of cool. So when you go from 30,000 to 60,000, even though the peaks are narrower, the number of data points sampled by Excalibur is the same. When I first saw this, I was like, this is great, because what that means is that you can use a single deisotoping method at 60,000 or at 30,000 resolution, it doesn't matter. Now, if you're running proteins and on the LTQ though, I've found that it's helpful to generate a model that kind of varies across the mass range. And just kind of zoom in to something on the left side of the spectrum and you can recenter the display. and then you can move this modeling box around. And then you can just tell it to model. And if you want to generate multiple models, you can click on that multiple models button and include your latest modeling peak. And generally I like to do like 3 or 5 peaks across the range, so I'll do another one here. Recenter the modeling box, put the box around the peak and say model again. Insert that model. Now what you can do is, if you find that the peak shape is not changing significantly, so if this is staying, this line that I'm generating is a flat line, then you really, that's telling you don't need multiple models. So we'll see what we end up with here. Generally what you find is it'll be on a line or it'll be a slight curve or something, but in that case, if the line is steep enough or there's enough curvature, then it's probably useful to have multiple models. So again, I'm just making my way across here, and you can see there's actually not much happening. It's staying fairly constant. You got to be a little bit careful with modeling data that's really noisy. So let's try this one. This might not be great. Let's see what that looks like. It's not a great peak, so I'm not going to use that one. This data, actually, I think I could get by with a single model, so I'm just going to do what it did initially. And I'm just going to remove all these. Where I've seen this, you need multiple models, is on the older QTOF instruments. When you're doing de-isotoping, it's kind of critical to have multiple models because the peak width is varying quite a lot. On the newer QTOFs, that doesn't seem to be the situation. So then I can just say next. Again, I'll say 2 here. At this point, if my goal is to generate a sharpened peak model, then I'm done. So I can take this result and save it as a method if I right-click on the display and get the export method box. Myoglobin sharp. So similar, if I go to ProMass now and just kind of restore a set of default parameters, and I paste in that myoglobin spectrum that I was working with, this is what I would get with regular ProMass, which looks pretty darn good. I could then apply that new method, sharp. So this should look a little better, and I think it does. So it's that versus that. Considerably more resolution there, which is cool.